Coal gasification is a multi-step process to convert coal into cleaner burning fuels. In one step, a coal sample reacts with superheated steam. So for A, combine the reaction above with the following two to write an overall reaction for the production of methane. So, okay. So they want us to basically, the professor went over this in week 2 lectures, but basically you want to cancel out the substances that are located on both the reactant side as well as the product side. Right away you can see that H2O is on both sides as well as CO and H2. And so we have to balance some of these because they won't be equal. Since we have 2 COs, we have 2 H2s. These 2 H2Os cancel and you'll have 1 extra, and so that's fine. This is the 1 extra. And then you'll have 1 CO on this side when there's 2 on the left. So the best thing to do here is to multiply this by 2. And if you multiply this equation by 2, that means you also have to multiply this by 2. So our new set of equations should be 2C plus H2O, or 2H2O. Let me just 2H2O, 2CO plus 2H2, CO plus H2O, CO2 plus H2, and then CO plus 3H2, CH4 plus H2O. So now we can cancel some of these. H2O for an H2O, we have 2 COs for 2 COs, and 3 H2s for 3 H2s. So now we have this left, 2C solid plus 2H2O gas, CH4 gas plus CO2 gas. That's what they're asking for, the reaction for the production of methane. Then they ask to calculate the delta H of the reaction, and that is basically just adding up these values. So 129.7, multiply that by 2, 259.4 plus negative 41 plus negative 206. I got 12.4. So that's the answer to part B. And then for part C, they're asking, using the value in B and calculating the delta H reaction for the combustion of methane, find the total heat for gasifying 6.41 kilograms of coal and burning the methane formed. Assume water forms as a gas and the molar mass of coal is 12 grams per mole. Okay. So they're asking for the heat in production of methane and the combustion of methane. So they're asking for the total heat for gasifying 6.41 kilograms of coal, and they're asking for the energy that would be done for burning the methane formed. Okay, so this is our equation. So we have 2C, which is coal, plus 2H2O is CH4 plus CO2. So one thing we know is that from part B, 12.4 kilojoules is absorbed per 2 moles of coal. And so now we have to calculate the heat for combustion of CH4. And for combustion of reactions for hydrocarbons, you would do CH4 plus O2, and you would get carbon dioxide and water. This part is always the same for hydrocarbons in combustion reactions. so that part is not going to change for hydrocarbons. So to balance out the reaction, we have 1O2 on the left side and 3 O's on the right. And then we have 1 H2s on the right side and 4 on the left. So the best thing would be to multiply this by 2. Because then you would get 4 H's, and then you would get 2O2, 2O2, and this would be just 2O2, so you multiply this by 2, you would have 4 O2s on both sides, and then it would be equal. So now it's balanced. And now you basically do, to find the delta H of the reaction, you'll have to do delta H F of the products minus the delta H F of the reactants. And you can find these values in your Appendix B. So we have the delta H formation of CO2 plus 2H2O minus the 2O2 and the CH4. So we'll do 2 times the delta H for water, so negative 241.826. Add that to 1 mole of CO2, negative 395.5. And then you subtract that whole thing from the from CH4 and 2O2. CH4 has value for the delta H formation, but oxygen doesn't. So for the 1 mole of CH4, which is negative 74.87, and then since O2 is 0, so we can just put zeros in. It doesn't matter. And then you'll just multiply these. And the value I got is negative 804.282 kilojoules per 1 mole of CH4. Okay, so now we have to basically base it off of the mass of coal that they give, because this value depends on how much coal that we have. So we can sort of like treat coal as the limiting reactant per se. So we get rid of this. We said that we have 6.41 kilograms of coal. We'll have to find out how much energy is given off by that coal, or like the total heat it takes for gasification of that coal. So we'll convert it to grams first. So 1,000 grams, 1 kilograms over, for 1 mole of coal, there is 12 grams coal. And then we know that it's 12.4 kilojoules per 2 moles. We found that previously. Cool. And then you do the calculations, and I got 3311.83 kilojoules. And now you have to find the total heat from burning the methane formed based on this many coals. So we have 6.41 kilograms of coal. You convert that to grams again, or 1 kilograms. You multiply that to get the moles. And it's 1 mole of CH4 for every 2 moles of coal, since we multiplied that top equation by 2, if you remember. And then for every 1 mole of CH4, we released this much energy, so negative 804.282. And now I got negative 214,810.3175. And now you basically add these two values. And I got negative 211,498.4875. So that is going to be the total heat, which is the answer to part C.